This video will touch on one of two dimensions researchers use when checking scores: reliability. As researchers, how do we know that the scores we assign to individuals correspond to the variables we want to study? We have to conduct research using the measure, and we have to demonstrate that they work. As an informal example, say Jim wants to start working out to put on muscle. He's been working out for the past 3 months and he looks more muscular. His friends comment on how he looks bigger, and he's had to buy bigger clothes. Now, if he weighed himself on a scale and the scale said he gained 20 pounds, that would make sense in the context of everything. If the scale said he lost 20 pounds, however, Jim would probably throw that scale away. So we have to evaluate the measurement methods that we use. We will talk about the first of two dimensions on how psychologists check this, which is reliability. Reliability refers to the consistency of a measure. Is it a stable measure, or do you get wildly different scores across people and situations? There are three main types of consistency that we will distinguish. They are test-retest reliability, internal consistency, and inter-rater reliability. Test-retest reliability. When we measure something that we assume to be invariant across time, then if we tested someone multiple times, they should get very similar scores across time. So test-retest reliability is the extent to which this is the case. Intelligence is a good example. Any good measure of intelligence will produce roughly the same scores for this individual today versus next week versus next month. If scores aren't consistent, then it's not a very good measure. So let's say I recruit 50 people to take 2 different IQ tests that I found online. These tests claim to assess IQ in just 10 minutes with just 10 questions. So we take all 50 people and have them take these 2 IQ tests at 2 different time points a week apart. Once all 50 people take the test, we can plot up everyone's scores. This is a scatter plot where the dots represent where everybody scored on the first attempt on the x-axis compared to the second attempt on the y-axis. This person here circled in red was measured at a little less than 90 on the first test, but was measured at 115 on the second attempt. Those are 2 very different scores. When you run a correlation between all 50 people on their 2 scores, with this you get a correlation of about 0.2. This is really low, and you can tell just from the scatter plot that there's no consistent pattern. We can then conclude from this first online IQ test that it's not reliable. On test number 2, however, scores on the first attempt are pretty similar to the second attempt for the majority of people. When you run the correlation here, it's about 0.87, which is pretty good. You can see here that the points neatly fall along the diagonal. We can therefore conclude that while the first online test was not very reliable, this IQ test is much more reliable. Like I mentioned, to quantitatively assess test-retest reliability, you look at the correlation between their 2 scores. A test-retest correlation of about 0.8 or greater indicates good reliability. Also, high test-retest reliability is only important on things that don't change over time. Some things that we measure, we know definitely changes over time, like mood. So in that case, we wouldn't be too concerned if the correlation between mood at 2 different time points was low, because we would expect that. Internal consistency refers to the consistency of people's responses across the items on a multiple item measure. Tons of measures have multiple items or questions. All items within a scale should then reflect the same underlying construct. So scores on individual items should all be correlated with each other. Take the purpose in life scale for example. This is a scale that measures, well, someone's purpose in life. These aren't the exact questions from the actual scale, but it gets the point across. Questions go a little like, my life is very worthwhile. I always see the reasons for being here. I'm a responsible person. I have discovered a satisfying life purpose, and you rate to what extent you would agree or disagree with those statements. It's clear that all those seem to reflect purpose in life, so they should all correlate pretty well together. That last statement, however, I enjoy historical fiction books, doesn't seem to be related to purpose in life at all, and it might not correlate well with the other items. If people's responses to different items are not correlated with each other, then it wouldn't make too much sense to say that they're all measuring the same underlying construct. We measure internal consistency using a split half correlation. The basic idea here is that you split the items into two arbitrary sets. This could be like the first half or second half of the set, or it could even be odd or even numbered questions, or something completely random. Then the score is computed for each set of items, such as the sum of all items in each set. Then finally, the relationship or correlation between the two sets is measured. A split half correlation like test-retest of 0.8 or greater is considered good internal consistency. The most common measure of internal consistency used in research that uses split half correlations is called Cronbach's alpha. I won't go too much into the weeds here on how this is actually calculated, but the calculation is slightly different. And the logic behind it basically is you calculate split half correlations between all possible combinations of items into two sets, and then you take the mean of that, and that's your Cronbach's alpha. Like test-retest, again, you would strive for at least 0.8 or above to indicate good internal consistency. A lot of measures require judgments from different observers or raters, and interrater reliability is the extent to which different observers are consistent in their judgments. You have two or more people watch the same video or occurrence and rate something. Assuming what you're measuring is detectable, then observer ratings should be highly correlated with each other. Take Bandura's Bobos, for example, or Bobo dolls. This was a study done by Albert Bandura in 1963. He was measuring observational learning to see how quickly children can learn or observe from, for instance, their parents. So in the experiment, he set up a Bobo doll in a room. And for those who don't know what a Bobo doll is, it's an inflatable toy that you can knock down, but it comes right back up into standing position because there are weights on the bottom of the doll. So first, a child would watch an adult go in and hit the Bobo doll, and then the child was left alone in the room. The children pretty much went crazy on the doll after that and would hit it a bunch of times. Here's a picture of one kid with a hammer in that poor Bobo doll. Anyway, say we were to measure the number of times that the kid hit the doll. We would then have two observers watch the same video and count the number of times they hit the doll. If both researchers are paying attention and it's easy enough to see when the child hits the doll, their ratings should be pretty similar. We measure interrater reliability using Cronbach's alpha when judgments are quantitative, or if somehow the judgments are categorical, the same statistic you would use there is called Cohen's kappa. So these are the three main types of reliability that we're concerned with as researchers, and we'll see you next time to talk about validity.